Welcome to One Chemistry. Always try to do your best. Now, let us see about 100 concepts in organic chemistry. We are seeing it as episode. This is the episode number 68. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the first question. They given the 3 different dienes there. First one is cyclic diene, where double bonds are conjugated. In second one, trans diene, one methyl group is attached there. Z1 also trans diene with methyl group. Here they ask you to find reactivity in Diels-Alder reaction. It is diene, it will be reacted with dienophile. You have to find which one reacts faster, which one reacts slower. So from the question of diene and the reactivity in Diels-Alder reaction, you might realize the question is really about structure versus reactivity. The answer is A. Let us see how. Here Diels-Alder reactions require S-cis bond. S means single cis bond, double bond connected through single bond, so it is called S-cis bond. So we have to bring all the structure to S-cis form. So we rotate the single bond there. So if you find it, the Y1 will be single bond with methyl group one nearby. This one methyl group is away from that. For the Diels-Alder reaction, there should be a less steric crowding. Then only dienophile will attack there. That's why Y reactivity will be very poor because of steric methyl group. If you look at the X, it is perfect one, ring, very rigid, it's a diene, and perfect for Diels-Alder reaction. So very high reactivity. Even though Z is a favorable S-cis form, the structure is not rigid. So the reactivity will be lesser than the X there. Because single bond can rotate, in X bond cannot rotate. So X will be the highest reactivity, Y will be the least one. So if you find the order X, Z and Y. So the answer is clearly A there. Here the concepts you have to learn here is Diels-Alder require S-cis double bond with less steric hindrance. Let us look at the next question. They are given the alpha beta unsaturated ketone and they given the lithium in liquid ammonia and tertiary butyl alcohol. They ask you to find the product. Here 4 products are given. 4 products are differ in the functional group. First one is amine attachment in the 4th position. Second one is tertiary butoxide in the 4th position. And the third one is just a reduction of double bond. And the 4th one is just a attachment of tertiary butoxide group. So from the question and reagents and different products, you might realize the question is really about the role of the reagent. What reagent can do in the reaction? The answer is C. Let us see how. Here you have conjugated ketone. You are using lithium and liquid ammonia. Here lithium in liquid ammonia is the electron donor. The electron is stabilized by ammonia. So the electron donation lead to the radical anion formation. It's an important intermediate. Then the anion conjugated by the alcohol, tertiary butyl alcohol. You have hydrogen there. Then you have radical. Radical has to be quenched. Again electron donation will be happen. You have anion formation. Again it will be quenched by the alcohol there. So after quenching of anion, if you look at it, the answer is C there. Here the concepts you have to learn here is lithium and liquid ammonia reduce the conjugated ketone. The lithium in liquid ammonia reduce the double bond in the conjugated ketone. Then let us look at the next question. Here they are asking which structures are having mesoform. Only M or both K and L or only L or only K. So from the 3 different structure and question of mesoform, you might realize the question is really about symmetry present in the cyclohexane. The answer is D. Let us see how. Only K compound is meso1, which has mirror plane inside. So what really happened is mirror plane bisects the middle carbon, it goes through the 4th carbon there. So the mirror plane is present on middle, it reflects each side nicely. So it will be the mesoform. If you look at the L1, it is a cis configuration. Cis you cannot have mirror image at all because both bonds are 120 degree to each other. Difficult to find the plane inside it. If you look at the M, the same thing. Again you have the trans relationship. It is impossible to have the mirror plane inside. So L and M are not mesoform. Only K structure is the mesoform. So the answer is clearly D, only K. Here the concepts you have to learn here is meso compound is the compound which have mirror plane inside, which will be optically inactive. Then let us look at the next question. You have the chiral compound and you are reacting with NaOT and ethyl alcohol. They ask you to find the products. The products can be substituted one or eliminated one. Eliminated one will be alkene. If it is alkene, they are asking whether it is cis or trans. If it is substitution, where the position of OH. So basically we are playing between substitution and the elimination. So from the question of chiral compound to the possible answers, you might realize the question is really about competition of substitution versus elimination. The answer is D. Let us see how. Here the reaction what really happens is E2 elimination. Why? Because H and OTS are trans to each other. So what really happens is first step you will have removal of H plus due to the base, you have anion formation. It can be easily understood by Saar structure. So we convert Newman projection into Saar's projection. So removal of anion, then the anion is there, then the anion pushes the OTS out, then you have final product alkene. If you look at the alkene, you might see CH3 on same side, so the product will be definitely D there. CH3 are syn to each other. Here elimination is favor, not the substitution, because you have leaving group and the stable anion formation possibility, because once the anion is formed, it's stabilized by phenyl group. So the stability of anion is there. You have trans eliminating group, which is anti-periplanar position. So only the elimination is the possibility. So the answer is clearly D there. Here the concepts you have to learn here is U2 elimination require anti-periplanar position of the atoms. Then let us look at the next question. They given the three different compound X, Y, Z. They are mostly acetal there. The acetal mean one is the bridged acetal, second one is the fused acetal, and third one is the acetal in the different ring system. One with phenyl, one with cyclic system. So basically three different acetal. Basically they are asking reactivity in the acid base hydrolysis. You have to find which one react faster. So the three structures are given, you have to find which one is which. Three structures are given, you have to find which one will have higher reactivity, which one will have lower. So from the question of three different acetals and the question of hydrolysis, you might realize the question is really about acetal stability versus hydrolysis. The answer is A. Let us see how. Here you have to learn the concept anomeric effect. Anomeric effect means what really happens is in acetals you have the trans bonds are there. One is oxygen with lone pair, another carbon is with antibonding orbital. Basically oxygen orbital is in orbital, the antibonding orbital is pi star orbital. What really happens is it have extra stability by anomeric effect. So what really happens is donation of electron from n to pi star. You might know from the molecular orbital theory, donation of the antibonding orbital leads to decrease in the bond order. Hence reactivity of acetals also increasing because you are breaking it up CO bond. So you are breaking CO bond better for hydrolysis. So the transposition is favorable for anomeric effect. So you have to find the structure with transposition which can help the hydrolysis of acetal. So if you look at the X, oxygen in the bridged carbon, so it will not work there. So transposition is not favorable there, so no anomeric effect. If you look at the Y, the positions are little bit twisted. It's not a perfect transposition because the orbitals are not perfectly aligned. If you look at the Z, orbitals are perfectly aligned. Anomeric effect is possible. So lone pair in proper position. Then Z will be reacting faster, X will be reacting slower. So the trend will be Z, Y, X. The answer is A there. Here the concepts you have to learn here is more the anomeric effect, higher the reactivity of acetals. Anomeric effect requires trans relationships. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.